Among the myriad scenarios for the ultimate demise of the universe, have you ever pondered which one evokes the most profound terror and despair? It is not the spectacle of colossal black holes devouring everything in a frenzy of gravitational tempests, nor the instantaneous annihilation wrought by gamma-ray bursts upon all existence. Far more harrowing is the prospect of absolute silence, a state in which no events transpire whatsoever. There would be no cataclysmic explosions, no lingering dust clouds, no dramatic collapses. Everything would simply cease. All stars, no matter how brilliantly they shine, would eventually flicker out. All black holes, regardless of their insatiable appetite, would evaporate into nothingness. The very atoms that form the bedrock of matter would halt their motion. At that juncture, this vast cosmos would transform into an endless slab of frigid stone, adrift in perpetual darkness. Light would fail to illuminate any path, heat would offer no solace, there would be no past to reminisce upon, nor any future to anticipate. Only an infinitely extended present would remain. This is an absolute void, a realm where time itself loses all meaning. Physicists refer to this demise by the chilling appellation of heat death. This is no mere plot from a science fiction novel, rather, it emerges from the most rigorous and dispassionate mathematical calculations derived from human intellect. What plunges us into even deeper despondency is the apparent impossibility of averting this outcome. Even if humanity were to advance technology to mythical heights, colonizing thousands of galaxies and extending existence across trillions of years, the inexorable arrival at that icy terminus could not be evaded. For heat death is not an external peril, such as extraterrestrial invaders or rogue asteroids, but an inherent flaw woven into the very fabric of the universe's design. It resembles an automobile traversing a motorway with a finite fuel reservoir. Irrespective of whether one drives swiftly or leisurely, the engine will inevitably sputter to a halt, leaving the vehicle stranded in the wilderness. Thus arise the agonizing questions: why does the universe bear this fatal imperfection, and who, or what, has ordained this inevitable and tragic conclusion? To comprehend this, we must revert to the most mundane observation, one that appears self-evident yet conceals profound cosmic secrets. Consider placing a cup of hot water upon a table. Why does it inexorably cool, whereas a cup of cold water does not spontaneously heat itself without external intervention? One might assert that heat naturally flows from regions of higher temperature to those of lower temperature. Yet pause to delve deeper: why cannot heat reverse its course, concentrating from the ambient air to reheat the cup? Physicists have contemplated this enigma for over a century, culminating in a startling revelation. It is not mechanically impossible, rather, the probability of such an occurrence is extraordinarily minuscule. So minuscule, in fact, that the entire age of the universe would prove insufficient to witness it even once. This encapsulates the merciless essence of the second law of thermodynamics. This law does not impose an absolute prohibition but delivers a death sentence predicated upon statistical probability. For ease of visualization, let us contemplate a simple yet weighty mathematical illustration. Suppose a sealed box contains merely 100 gas molecules. Initially, all molecules are confined to the left half of the box by a partition, representing a state of extreme order where each molecule's position is precisely known. Upon removing the partition, how do the molecules behave? They dart about chaotically, colliding with one another and the walls, ultimately distributing themselves uniformly throughout the box. This constitutes a disordered state, one of high entropy. The query arises: could these randomly flitting molecules ever spontaneously recongregate in the left half, as they were at the outset? In theory, physics permits it, for the molecules' motions are stochastic, and any configuration possesses a certain probability. But what is that probability? For 100 molecules, the likelihood of their gathering on one side approximates 1 over 2 raised to the power of 100. In other words, to observe this box and anticipate witnessing such a miracle, one would need to wait approximately 10 raised to the power of 30 seconds. How protracted is 10 to the power of 30 seconds? It exceeds the current age of our universe by more than 200 billion times. And this pertains solely to 100 molecules. In reality, a liter of air that you inhale contains roughly 10 to the power of 22 molecules. To await this liter of air spontaneously congregating in one corner of a room, leaving a vacuum elsewhere, would demand a duration beyond the expressive capacity of any human numeral or language. This elucidates why scattered playing cards do not spontaneously leap into orderly stacks, why shattered vases do not self-reassemble, and why cooled coffee does not spontaneously boil. It is not that physical laws forbid it, but that probability renders it untenable. Now, extend this unrelenting logic to the scale of the entire universe. The universe emerged from the Big Bang in an exceedingly hot and dense, ordered state. All energy and matter were compressed into a singular point. This marked the universe's nadir of entropy, its pinnacle of order. Subsequently, the Big Bang ensued, space expanded, energy diffused, temperatures plummeted. Matter coalesced into stars, planets formed, life arose. We perceive the complexity of life and civilization as augmentations of order, yet the harsh verity is that all these phenomena consume the universe's overall order. Each instance of stellar nuclear fusion radiating light, each transfer of heat, each chemical reaction within your body, contributes to the universe's escalating disorder. The universe resembles a colossal, pristine ice block gradually melting. During this melting, the ice might form refreshing streams, be sculpted into exquisite forms, or nurture abundant life. Yet the melting process is irreversible. Once the ice block has fully liquefied into water, it will not spontaneously refreeze into its original shape. So, how long until this cosmic ice block dissolves entirely into oblivion? Presently, we occupy a position 138 billion years post the universe's inception. From this vantage, let us trace the final odyssey. In 10,000 years, human civilization might still flourish or have perished through hubris, but the expansive universe would remain indifferent. Stars persist in their combustion, galaxies continue their gravitational waltz, all appearing much as tonight's sky. 40 billion years hence, our Milky Way and the Andromeda Galaxy will collide in a spectacular merger. These two immense structures, each harboring hundreds of billions of stars, will pass through one another like phantoms. Gravity will rend asunder the old order, hurling innumerable stars from their orbits into the chill of space. Yet this is not destruction but agonizing reconfiguration, birthing a new supergalaxy. 100 billion years onward, the universe's accelerating expansion will propel distant galaxies beyond our observational horizon. Should intelligent life endure then, they would perceive the universe as comprising solely their own galaxy. All else would vanish into eternal obscurity, beyond the boundary where light can reach. The universe devolves into a collection of isolated islands, drifting infinitely, never to reconvene. 1 trillion years later, the raw materials for star formation, hydrogen clouds, begin to deplete. The cradles of stars shutter, rendering new stellar births scarce. The universe enters an era of stellar deserts, where only aging stars linger feebly. 10 trillion years hence, the final stars exhaust their fuel and extinguish. Natural light sources in the universe vanish. Complete and utter darkness envelops all. But this is not the terminus. The stellar corpses bequeath remnants such as white dwarfs, neutron stars, and black holes. These endure like eternal sepulchres in the cosmic graveyard. However, even what we deem the most indestructible matter yields before time. According to the latest research from 2025, including studies published in journals such as Physical Review D and advancements from observatories like the Dark Energy Spectroscopic Instrument, proton decay, the disintegration of the fundamental constituents of atomic nuclei, commences around 10 to the power of 37 years from now. All atoms disintegrate. Rocks, metals, bones, all solid matter dissolves into a morass of elementary particles and radiation. Every trace of civilizations, every legacy, every memory is utterly erased from the plane of existence. Further, 2025 investigations, drawing on refined models of Hawking radiation and quantum effects, indicate that white dwarfs and neutron stars evaporate and vanish around 10 to the power of 67 years hence, a timeline significantly accelerated from prior estimates of 10 to the power of 100 years. The mechanism of Hawking radiation will dissipate even the mightiest black holes, those voracious devourers of light. By then, the expansive universe retains only photons, electrons, positrons, and a profusion of ghostly neutrinos. These particles drift ever farther apart due to spatial expansion, wandering through infinite voids. And thereafter? No further events unfold. The universe's temperature approaches absolute zero. All particles cease thermal motion. Time forfeits significance, for time is gauged through change and sequential events. Absent events, absent change, time halts. It resembles a computer screen eternally displaying the same static image. One cannot discern whether it is a photograph or a paused video. This is heat death, not a demise heralded by tolling bells, but a silent fading, a descent into eternal slumber from which there is no awakening. Upon hearing this narrative, dread may well up within you, prompting the query of whether any escape from this grim destiny exists. Humanity's most brilliant minds, scientists, grapple ceaselessly with this same interrogation. They proffer tenuous yet luminous hypotheses akin to beacons of hope. The first posits that the universe may not be the closed system we presume. The second law of thermodynamics decrees that entropy in a closed system invariably increases, but what if our universe is open? Should parallel universes exist, permitting energy influx from elsewhere, like replenishing fuel, then the entropy augmentation law ceases to be a death warrant. Nevertheless, empirical evidence for multiverse remains elusive as of 2025, confined to mathematical equations on paper. Another glimmer arises from gravity. Certain physicists contend that heat death theory overlooks gravity's intricate role, considering only pure thermodynamics. Gravity aggregates matter, forging ordered structures like stars and galaxies, seemingly countering entropy's chaotic proclivity. Gravitational systems lack conventional stable thermal equilibria. Thus, the universe might never attain complete heat death. Yet this assertion faces immediate rebuttal. Other physicists highlight that when gravity clusters matter into stars, the heat and radiation emitted engender far greater disorder than the internal order gained. Hence, gravity does not reverse entropy's flow but constitutes part of its inexorable progression. The most imaginative and philosophical third possibility is that the universe might reboot itself. This embodies the notion of eternal recurrence. If the universe originated from a low-entropy singularity, could random particle fluctuations, over sufficient time, spontaneously reorder into that state? Physics harbors the Poincare recurrence theorem, asserting that over adequate durations, any system returns to a configuration proximate to its initial state. But what constitutes adequate time here? Scientists have computed this for the observable universe, yielding a staggering figure, 10 raised to the power of 10, then to the power of 120 years. Human language or imagination falters in grasping this expanse. Thus, mathematically, the universe might recur, but experientially, it equates to eternity. The universe, through 138 billion years of arduous evolution, encompassing innumerable stellar life cycles, has fashioned eyes capable of gazing upon and comprehending itself. We humans are those eyes, the universe's consciousness. We are the means by which the universe apprehends itself. Therefore, the next time you feel this life minuscule and meaningless before time's cruelty, recall this: you are the quintessence of 138 billion years of evolution. You are a probabilistic miracle yet unswallowed by entropy's augmentation law. You are the brightest and warmest flame preceding the eternal night of heat death. Your existence, though fleeting, attests that the universe is no mere cold stone and inert gas. Live well, love, and explore. That is the finest, most dignified stance we can adopt en route to awaiting oblivion. When the inaugural scientists commenced calculating heat dissipation, they foresaw the end of all things and felt a bone-chilling solitude. Only later did we grasp that by scrutinizing that ultimate darkness, we cherish the present light more profoundly. Each heartbeat, each ignited thought, is an irreplaceable treasure. We owe profound gratitude to those great intellects who, in quiet chambers throughout their lives, contended with frigid equations and merciless numerals to chart the universe's destiny. Pioneers, your courage in staring unflinchingly into entropy's abyss, confronting thermodynamics' harsh truths, we salute. Thanks to you, humanity dwells not in obscurity but comprehends its identity and position within time's boundless flow. Through apprehending the universe's finitude, we aspire to diminish senseless strife, dedicating precious time to love and creation. Though natural laws decree some shall fade into nothingness, the understanding and gratitude bequeathed by human wisdom shall resonate as the proudest echo in the universe's serene ocean, reverberating eternally. Yet that proud echo, however resonant, cannot arrest the wheel of physical laws. If heat death is the suspended death sentence, then the specific mechanisms of the universe's late epochs conceal a cold yet majestic beauty, unveiling a solitude the human mind cannot fully encompass. Shifting gaze from entropy's overarching landscape to focus on future's concrete particulars, more precise and isolating scenes emerge from the gloom. That is the degenerate era, the moment when the grand energy factories we know as stars cease operations entirely. Envision a sky bereft of the radiant glow from sun-like main-sequence stars. Billions of years hence, when hydrogen fuel depletes, medium-sized stars swell into red giants, shed their envelopes, and leave exposed white dwarf cores. But smaller stars, those parsimonious red dwarfs that burn slowly and conserve fuel, shall serve as the final witnesses to the epoch of light. They endure for trillions of years, dimming like the embers of a dying hearth. Ultimately, however, they too wane. When the universe's last star extinguishes, we enter what astronomers term the degenerate era. The cosmos no longer stages vibrant life but becomes a vast necropolis teeming with celestial cadavers, chilled white dwarfs, dense neutron stars, rapacious black holes. In that silent obscurity, these corpses are not wholly inert. Occasionally, through gravitational wave emission sapping orbital energy, two white dwarfs or neutron stars spiral into collision. Such events trigger type Ia supernovae explosions, briefly rending the eternal night like the universe's whimpering reminiscence of its golden past. But these are rare exceptions. The era's dominant decree is dissolution. The ordinary matter composing our bodies and the ground beneath our feet proves less enduring than imagined. Grand unified theories in particle physics predict that protons, the fundamental building blocks of atomic nuclei, can decay. If voracious, and 2025 updates from experiments like those at the Supercamiocande Observatory and theoretical refinements in physical review letters suggest lifetimes exceeding 10 to the power of 34 years but potentially variable in cosmic contexts, then over durations defying conventional notation, matter spontaneously perishes. The universe's most obdurate stones, white dwarfs and neutron stars, gradually vaporize into charged particles and radiation, dissipating like smoke into the void. At that point, the universe harbors only black holes. They ascend as absolute sovereigns of an empty realm. The black hole era commences. Yet these light-devouring behemoths are not immortal. The eminent physicist Stephen Hawking demonstrated that, owing to quantum effects at the event horizon, black holes emit thermal radiation, now known as Hawking radiation. This process unfolds excruciatingly slowly for massive black holes. A solar mass black hole requires 10 to the power of 67 years to evaporate fully. Supermassive black holes at galactic centers demand even longer. Over that interminable span, black holes shed mass, contract, and heat up. In their dying throes, they unleash immense energy as gamma rays, fleetingly illuminating surrounding space before vanishing utterly. When the final black hole dissipates, all macroscopic structures in the universe conclude. However, this decay panorama remains incomplete without acknowledging the universe's overarching dramaturg, dark energy. While matter and gravity endeavor to draw everything closer, dark energy, an intrinsic energy form permeating space, thrusts all apart with increasing velocity. Dark energy's essence ranks among modern physics' paramount enigmas. It constitutes the bulk of the universe's energy density yet remains utterly invisible and elusive. Recent 2025 findings from the Dark Energy Survey and the Dark Energy Spectroscopic Instrument, as reported in publications like Nature Astronomy and Science Daily, intimate that dark energy's density may not be constant but diminishing over time, challenging prior assumptions of eternal acceleration. If dark energy's density holds steady, the universe inflates perpetually, galaxies light unable to bridge the voids. Surviving civilizations' night skies would embody absolute, lonely darkness. This is the big freeze, the chilled death scenario. But a more terrifying alternative is the big rip. Should dark energy intensify temporarily, as explored in 2025 models of phantom energy, it would not merely sunder galaxies but overpower gravity-sustaining stars within them, electromagnetic forces binding electrons to nuclei, and ultimately rend spacetime's fabric. In this tableau, all matter, from colossal stars to minuscule atoms, is shredded into elementary particles incapable of interaction. The universe culminates in violent, thorough obliteration, where even distance loses meaning. Beyond this, quantum physics introduces a more insidious and unforeseen menace, false vacuum decay. Per the standard model of particle physics, the Higgs field imparting mass to particles may reside not in its lowest energy state, its most stable configuration, but in a metastable false vacuum. Visualize the Higgs field as a ball in a valley on a hillside. Yet beneath that valley lies a deeper abyss. Should quantum fluctuations propel the ball over the intervening ridge into the abyss, the universe would face transition to a true vacuum. A true vacuum bubble would nucleate, expanding at light speed, altering fundamental physical constants within. Inside that bubble, matter as we know it could not persist, chemistry disintegrates, fundamental forces transmute. This death bubble engulfs everything without forewarning, propagating at light speed, so we perceive no approach. One instant we exist, the next, we are expunged from reality, like deleting a line of code in a computer. 2025 theoretical research, including simulations using Rydberg atom arrays and quantum annealers as detailed in Nature Physics and R14 preprints, has advanced our comprehension of false vacuum decay dynamics, demonstrating bubble nucleation in controlled quantum systems and underscoring the precariousness of our cosmic stability. Additionally, emergent 2025 theories propose the universe might conclude in a reverse Big Bang, dubbed the Big Crunch, rather than perpetual expansion. A cadre of researchers, including those at Cornell University and in studies published in Physical Review D, predict that if dark energy wanes, evidenced by mounting data suggesting a negative cosmological constant, the expansion halts and reverses, culminating in a colossal fireball collapse approximately 33 billion years from now. This contests long-standing views of eternal inflation, implying a more dramatic terminus. Moreover, novel computations from 2025 indicate white dwarf and neutron star decay transpires far swifter than previously envisaged, potentially within 10 to the power of 37 years, truncating the universe's lifespan timeline. There are even hypotheses positing energy fragments as the cosmos's fundamental constituents, supplanting particles and waves, which could upend our grasp of space and time, hinting at a more fragmented finale. Amid these cold and merciless destruction scenarios, where do humans, or our successor intelligences, stand? Survival instincts would impel future civilizations to realize feats today confined to novels. As stars extinguish, they might erect colossal structures around black holes, extracting energy from accretion disks or via the Penrose process harnessing rotational energy. Consciousness could transfer to non-biological forms, inhabiting vast quantum computer networks, subsisting on cosmic remnants, decelerating subjective time so that a real-world second spans millennia in virtual realms. Escaping entropy would constitute life's grandest, most poignant migration, an asymmetrical war between existences will and thermodynamics iron edicts. Yet, regardless of technological prowess, prolonging existence across trillions of years, the ultimate destination remains stasis. Confronting that inevitability, reality's beauty crystallizes most vividly. We recognize the universe owes us no eternity. The universe and we within it are a finite gift. That finitude begets value. Flowers derive beauty from wilting, music excels through conclusion, life gains preciousness from impermanence. Entropy, seemingly annihilating all, actually propels change. Without entropy's increase, no arrow of time exists, past and future blur indistinguishably, no events occur, no narratives unfold. We are entropy's progeny, born from chaos, seeking order, ultimately returning to chaos. When the earliest astronomers discerned the universe's accelerating expansion, they recoiled at the distant future's empty skies, nearby galaxies forever vanishing from view. Only later did we comprehend that cosmic solitude serves as the harshest yet truest reminder of connectivity. In this ephemeral epoch where galaxies yet behold one another, where atoms still bond to forge life, we share a rare privilege. We bow in gratitude to the titans of quantum physics and cosmology, those who pose the boldest queries on beginnings and ends, illuminating spacetime's darkest recesses with mathematical language, venturing where human intuition dares not tread. Torchbearers, thanks to you, we, mere dust on a floating rock, grasp the births and deaths of stars and eternity's brink. Through comprehending the universe's vastness and austerity, we hope humanity seeks unity's warmth amid darkness, cherishing mutual existence, eschewing trivial schisms. Dark energy and entropy's gloom may engulf some, but humanity's ignited curiosity, thirst for understanding, and courage to confront truth shall endure as the proudest legacy, a diminutive yet tenacious flame, indelibly persisting in the universe's memory. The night sky we gaze upon with awe and dreams is, in truth, a velvet curtain veiling astrophysics' cruelest scenes, concealing that material existence is but a transient interlude in oblivion's infinite flow. The fragility sustaining the false vacuum state compels us to confront that the universe is not designed to preserve life. Instead, it operates as a cold mechanism engineered to efface all traces of order and structure. The Higgs field's collapse looms like an unheralded death, a falling blade, while dark energy and accelerating expansion scenarios proffer a protracted demise over trillions of years, with solitude as lifelong torment's protracted affliction. Envision an invisible force, an energy phantom permeating every millimeter of space, propelling all asunder with mounting ferocity. That is dark energy. Initially, it whispers faintly against gravity, permitting stars and galaxies to cluster. But as time elapses, the universe inflates, matter density dilutes, and dark energy maintains or, in phantom scenarios, escalates its density. Presently, the cosmos does not merely enlarge but rends. The universe's grandest edifices, galaxy clusters, are the inaugural casualties. Gravity, that diligent architect binding galaxies over billions of years, wearies before dark energy's invincible thrust. Galaxies detach from their clusters, drifting into infinite blackness like islands swept by a colossal storm across a central ocean, never to reunite. In the Big Rip scenario, dark energy's devastation spares no structure, not even the minutest. Post-galactic separation, this thrust infiltrates galactic interiors. Our resplendent spiral abode, the Milky Way, is dismantled piece by piece. Spiral arms fracture, stars are flung from orbits, wandering solitarily through frigid space. Then the horror visits each stellar system. In the final days, should Earth persist, the night sky is utterly dark. No Milky Way band, no familiar constellations. The yet unextinguished sun is a receding solitary beacon. Dark energy overcomes solar gravity, tearing Earth from orbit, disintegrating planets. Rocky mantles, oceans, atmospheres are stripped, scattering into the void. The tragedy's crescendo arrives when space inflates superluminally at microscopic scales. Atomic bonds shatter. Electrons are ripped from nuclei, and ultimately atomic nuclei, matter's elemental bricks, are sundered. The universe concludes in total disassembly, where no particle can interact with another in absolute isolation and perpetuity. Yet if dark energy proves insufficient for a big rip, we pivot to a more serene yet equally sorrowful vista, heat death. This is entropy at its zenith. In this prognosis, the universe does not tear but senesces. Stars are machines transmuting matter into energy and light, but fuel is finite. The day arrives when the universe's final hydrogen cloud condenses to ignite the ultimate star. That star extinguishes, and the cosmos enters the decay era. The firmament becomes a graveyard of celestial corpses, white dwarfs, neutron stars, black holes. These gradually cool and dim, equilibrating with the near-absolute zero temperature of surrounding space. In eternal darkness, time loses import. Time is measured via change and event sequences. When the universe attains thermal equilibrium, no heat transfers, no motions, no life. All enters millennial slumber. Even the greediest monsters, black holes, cannot elude fate. Per Stephen Hawking's theory, black holes radiate and evaporate progressively. This unfolds beyond human imagination's slowness, with supermassive black holes potentially requiring quintillions of years. But on eternal scales, it is a blink. When the last black hole erupts in feeble luminescence, the universe retains only an infinitely diluted sea of photons and elementary particles. So sparse that two particles never encounter one another in remaining time. This is absolute stasis, the end of all tales, where past is effaced and future never arrives. Confronting these prospects, humanity often feels diminutive and purposeless. If all terminates in nothingness, what avails the endeavors to erect civilizations, craft artworks, make scientific discoveries, or kindle love? Are we children building sandcastles before entropy's wave sweeps all away? Yet within that despairing query lies the most resplendent answer. Life's meaning resides not in eternity but in being. We are the universe's mode of self-recognition. We are the eyes appreciating cosmic beauty, the intellects deciphering rules, the heart sensing pain and joy. Even as matter decomposes and stars fade, the moments we live, love, and comprehend are undeniable verities. We edge, humanity, upon time's slippery surface. Perhaps none shall read it, but its existence is eternal truth. In oblivion's war, our sole armament is memory and knowledge. Those who hone this armament, peering into the end's abyss to seek truth's light, scientists, humanity's grand pioneers. When Edwin Hubble first realized galaxies recede from us, or theoretical physicists computed proton decay's feasibility, humanity endured profound spiritual shocks. We recognized we stand not on eternal solid ground but adrift on a fragile raft in time's evaporating ocean. Extinction's fear, space's chill, envelops the most sensitive souls, rendering us acutely lonely amid countless stars. Only later did we understand that harsh finitude is the mightiest motivator to cherish each present instant. Knowledge of the universe's end does not render life meaningless but transforms every breath, thought, and connection into an incredulous rare miracle. We acknowledge coexisting in this era where stars yet gleam and energy abounds as an improbable privilege. We extend profound thanks to astrophysics and cosmology's great minds, those who decode stars' secret tongues lifelong. Those who sit patiently by telescopes through cold long nights, mapping the universe's grand yet sorrowful panorama with arid equations. Your courage and wisdom, thanks to you, we know our place in time's flow, living not as blind in darkness but confronting destiny with understanding and pride. We hope, through awakening to our fragility before the cosmos, humanity discards petty hatreds and meaningless quarrels, drawing nearer one another. Dedicate this finite time to love, creation, safeguarding the knowledge flame arduously kindled by ancestors. Not fearing future darkness but wielding its understanding as a beacon, guiding us to fuller, more meaningful lives. Matter and energy ultimately kneel before thermodynamic laws, vanishing into nothingness, but the pursuit of truth, the yearning to comprehend origins and destinations, is humanity's consciousness intoning the most poignant heroic ode amid the universe's eternal silence. A diminutive yet proud resonance, asserting we were here, we thought, we gazed into infinity's eyes. In all this, we extend profound gratitude to the scientists, researchers, research groups, and their contributions mentioned. Stephen Hawking, Edwin Hubble, and all who, through recent studies, unveil the universe's fate more deeply. Your persistent efforts, quiet dedication, commitment to advancing human and societal knowledge, are the illuminating rays unraveling cosmic mysteries and inspiring us. Without your courage and wisdom, we would still dwell in darkness. Thank you.